All right, guys, here's your review for quiz 5. Question number 1, we see the square root of 13 minus square root 3 divided by square root 13 plus square root 3. We have to rationalize this denominator. And to do that, we're going to multiply the denominator times the inverse here. So instead of square root 13 plus square root 3, we're going to multiply by square root 13 minus square root 3. That means we also have to multiply that numerator times the same expression. And when we do that, what we notice is our square root 13 times itself is going to give us 13 without that radical expression. Then square root 13 times minus square root 3 gives us negative square root 39. Positive square root 3 times square root 13 gives us square root 39, and this time it's positive. And then the last two terms, square root 3 times square root 3, and this is a minus, so square root 3 times minus square root 3 gives us minus 3. In the numerator, we distribute as well. Square root 13 times square root 13, we get 13. Then the square root of 13 times minus square root 3 gives us negative square root 39. The two center terms, negative square root 3 times square root 13 gives us negative square root 39. And then negative square root 3 times negative square root 3 gives us positive 3 without that radical. So in the numerator, we can add that 13 plus the 3 on the end. So that gives us 16. Also, we'll combine negative square root 39 minus negative square root 39. That gives us negative 2 square root 39. In the denominator, that negative square root 39 and positive square root 39 cancels out, leaving 13 minus 3, and that's how we get 10 in our denominator. We get 10 here in the denominator. Now 16, 2, and 10 can be simplified further, so we divide by 2. 16 divided by 2 gives us 8. And then 2 divided by 2, that becomes 1. So we just write negative square root 39 here. And then 10 divided by 2 gives us 5. So this is our final answer. 8 minus square root 39 divided by 5. You want to make sure you reduce to lowest terms. For the next question, we have the cubed root of 192 times x to the 11th power y to the 7th plus 3x cubed y squared times the cubed root of 24x squared y. Now this 192, we simplified by finding the largest perfect cubed number that can be divided into 192, and that's 64. The factors are 64 times 3, that gives us 192. Now with the x terms, we see x to the 11th power, which is not a power or a multiple of 3. So the next or lowest multiple of 3 closest to 11 would be x to the 9th power. So when we divide that, we'll get 9 with 2 left over. So we factored x to the 11th using x to the 9th, that's the closest power of 3, times x squared, since we had 2 left over. We do the same thing with the y to the 7th. We factored it using y to the 6th power times y to the 1st power. So that 1y here. I circled those 64x to the 9th and y to the 6th power because those can be simplified further. The cubed root of 64 is 4. The cubed root of x to the 9th power is x cubed. And the cubed root of y to the 6th power is 2. Now, how do we get those? Again, we're just dividing by 3. And what's left over is the cubed root of 3. That 3 stays underneath the radical expression, x squared and y. Plus, we carried down here the next terms, which were 3x cubed y squared. But see, we circled that 8 because 8 is a perfect cube number. We used 8 when we factored 24. 24, the largest perfect cube number that can go to 24 is 8 times 3. And the cubed root of 8 is 2. So we multiply 2 times the 3 in order to get 6 times that x cubed y squared, and what's left underneath that cube root is 3x squared y. Now see, we have 4x cubed y squared plus the 6x cubed y squared. Both of these are multiplied by the same radical expression, the cube root of 3x squared y. Therefore, we can add them together. So 4 plus 6 gives us 10 x cubed y squared times the cube root of 3x squared y. This is our answer. For the next problem, we have a negative outside of the square root of 11 to the fourth power. 11 to the fourth power is 1,000 or 14,641. We take the square root and we'll get 121. Just remember to carry over that negative. So the answer should be negative 121. The next problem, we have the fourth root of 2 minus 7m raised to the fourth power. Now, if we change that radical form to exponential form, remember the base underneath the radical expression becomes the new base of our exponent. Our denominator comes from the index, which is 4, and the power is going to be our numerator. 4 divided by 4 is just 1, right? This is just equal to 1. So 2 minus 7m to the power of 1 is just itself. So that answer should be 2 minus 7m. Next, we have I raised to the power of 56. So when we're looking at the letter I, we discuss I squared is equal to negative 1. So I wrote here the 4 different solutions you should get when you're using powers of the letter I. So I to the first power, we know it's just going to be I. It will be I itself. I squared, we know is negative 1. But what about I cubed? So I know that I squared is equal to negative 1. But when I multiply it times another letter I get negative I. I to the fourth power, that's 2 of these I squared. So that's negative 1 times negative 1. And negative 1 times negative 1 gives us positive 1. So the powers, if we continue to raise I to the next power, which will be I to the 5th, then we'll wind up with another I. This pattern of 4 numbers will continue. We'll get I for the next one. I to the 6th power, we'll get negative 1. Then we get another negative I, and then we get a positive 1. Next would be another I, so that pattern continues. So what you want to do is start out by looking for multiples of 4. We start with our 56, and we want to see if that number itself is a multiple of 4, because if it is, any multiple of 4 will give us a solution of 1. 56 divided by 4, it does give us a whole number, 14. So we know that 56 is a multiple of 4. Therefore, I to the power of 56 is going to equal 1. The next question, we're dividing. We have 2 minus 10i divided by 1 minus 9i. Again, we got to get rid of this imaginary number in the denominator. So we multiply it by 1 plus 9i. Both numerator and denominator, and then we distribute. So 1 times 1 gives us 1. 1 times 9i gives us positive 9i. Negative 9i times 1 gives us negative 9i. And then negative 9i times 9i, that gives us negative 81i squared. Now we went ahead and crossed out the positive 9i and negative 9i in the denominator, and circled this I squared, because remember I squared equals negative 1. And negative 1 times that minus 81, that gives us positive 81 in the denominator. So the 9 i's cancel, and we had 1 in front. So 1 plus 81 makes our denominator 82. In the numerator, we distribute as well. 2 times 1 gives us 2. 2 times the 9i gives us 18i. 1 times negative 10 gives us negative 10i. And then negative 10i times 9i is minus 90i squared. Again, I squared equals -1 times that -90 will make that a +90. We carry down the 2. And in the middle, 18i minus 10i gives us +8i. We go ahead and combine 2 plus 90, we'll get 92 plus 8i over 82. This can be simplified further. We divide each of these terms by 2. So 92 divided by 2, we get 46. 8i divided by 2 gives us 4i. And then 82 divided by 2 gives us 41. So this is our answer, 46 plus 4i over 41.